Hello friends, this is my 25th lecture in Signal System series. My name is Nishtha Verma. The topic which I am going to cover in this lecture will be the shortcut to find the roots of quadratic equation, because in Laplace transform, in every equation we have to find the quadratic equation roots. That's why I tell you the one shortcut method, and then gate numerical I will discuss based on Laplace transform. So shortcut to find the roots of quadratic equation. So here what if suppose equation is 3x square plus 8x plus 4 equal to 0. So you can see that over here it is plus and plus. If sign of the equation is plus and plus, the roots will be minus minus. So it means the roots of the equation will be minus minus. After that, what we will do, we will multiply the first and the last term. Here it is 4 into 3 is 4 3s are 12. So we know that now we have to break the 12 in such a way that its value should be, summation of subtraction should be equal to 8. So we know that 6 and 2. So 6 and 2, right? So 6 and 2. So now this is not the final answer, because with x square 3 is also there. So now what we will do, we will divide the roots by 3. So now the final roots will be minus 2 and minus 2 by 3, right? In the same way, if equation is x square plus x minus 20, so we can say, see here plus sign and it is minus sign is there. So we know that for plus minus the roots will be minus plus. So our root will be with sign minus and plus, right? So when we multiply, here one number is there and here 20. So 20. So what we can do, how we can divide, how we can add or subtract to get 1. 5 4s are 20. So 5 and 4, because here with x square one integer is there, so the values will remain same. So roots will be minus 5 and 4. In the same way over here, plus and minus is there. So plus minus is minus and plus roots will come. So we will multiply 1 into 6 is 6. So 6 can be break into 3 and 2. So 3 2, right? So in this way we can find the roots very quickly. So now the thing comes, how we will remember the sign of the roots. Always remember is, if plus plus is, if first position is plus, then first position sign as well as second position both sign will change. So plus is here, so it become negative, and then next is plus, it will be negative. So but now if minus is there, for at first position minus is there, then first position sign will change but second position sign will remain as it is. So minus will become plus, but here second position will be minus, it will remain as it is. Again, if plus first position plus is there, then it will change the sign of both the positions. So plus become minus and minus become plus. So here at first position minus is there, so it will change the sign of only first position. So minus will become plus and plus will remain as it is. So in this way, it is one of the easiest method to find the roots of the quadratic equation. Now numerical one. So if equation is given to us 3s plus 1 upon divided by s cube plus 4s square plus k minus 3s, it is given that if limit t tending to infinity ft equal to 1, then we have to find the value of k. If you remember the final value theorem, in final value theorem, if limit t tending to infinity was there in the time s domain, it become s tending to 0 and s multiplied by fs. So fs here it is given as 3s plus 1. In the denominator it is s cube plus 4s square plus k minus 3 into s, right? So here we can take s tending to 0. Numerator will remain as it is, and in the denominator s we can take common, it become s square plus 4s plus k minus 3. So S will be cancelled out. When we put S is equal to 0, we will get 1 upon k minus 3, and it is already given its value is equal to 1. So when we place it equal to 1, we will get k minus 3 equal to 1, that is k equal to 4. So answer will be D. Now next is, a system is described by the following differential equation where ut is a unit step function and yt is the output. The equation is given and we need to find yt. So we know that how to find the Laplace of differential equation. Here differentiation is there, so we know that y dash t can be written as s ys minus y0, that is initial value, it is already given, plus 5ys plus is equal to ut Laplace is 1 by s. So ys we can take common, it become s plus 5, and y0 value is minus 1 is equal to 1 by s. So that minus 1 we can take right side, so it will become plus 1. When we will do, it will become 1 plus s at the numerator, in the denominator it will come s plus 5. Now we need to take the partial fraction a by s plus b upon s plus 5. Now we need to find, when we put s equal to 0, in that case it become 1 upon 5. So a value will be 1 by 5 by s. Then b value, for finding b value, we will place s equal to minus 5. That is 1 minus 5 upon minus 5. It will become minus 4 upon minus 5. Minus minus will be cancelled. So it will become 4 by 5. S plus 5. When we take the inverse, we will get 1 by 5 is nothing but 0.2, and it will become 4 by 5 is 0.8 e to the power minus 5t. So answer will be A. So in this numerical, the question is given, the Laplace transform of continuous time signal is given if the Fourier transform of the signal exists. So here axis is given as 5 minus s upon s square minus s minus 2. So first of all, we will find the roots. We know the method, s square minus s minus 2 is there. If minus minus is there, so always remember the root sign will be plus and minus, and 2 is there, so 2 and 1, right? So the roots we will get 5 minus s upon it will be s minus 2 and s plus 1. So this will be the root. So here it is given Fourier transform should exist. We should remember that for Fourier transform, if two roots are there, plus 2 is there and minus 1 is there, it is j omega axis. So for Fourier transform to exist, the final ROC of which will come after the implementing minus 2 and plus 1 both, it should include j omega axis. If j omega axis will be included in final ROC, then only the Fourier transform will exist. So if suppose we will take we take the partial fraction, so it will become a upon s minus 2 plus b upon s plus 1. So when we put s equal to 2, so it will become 5 minus 2, and 2 plus 1 is 3, so it become 3 by 3, that is 1 upon s minus 2. And when we put s equal to minus 1, so it will become 5 plus 1 it will become, and instead of s minus, so minus 1 minus 2 it will become 6 minus 3, that is minus 2. So it become minus 2 s plus 1, right? So if we take s minus 2 as right sided sequence, then ROC will be here, and if I will take s plus 1 also at the right sided sequence, then ROC will be here. So when two functions are there and we need to find the final ROC, then we take the common area. Then we can see that the common area will be come from plus 2 to infinity. So definitely it is not going to include j omega x's. So for that, what we will do, we will take this this s minus 2 as a left sided sequence. So for taking it left sided sequence, it become minus e to the power 2t u minus t, and here it will become 2 e minus t ut. So in this case, when it become left sided and this is right sided, then only j omega x's will be included. So our answer will be C. Now next is the inverse Laplace transform. It is very simple. Just we have to find the inverse Laplace. S plus 5 upon s plus 1 and s plus 3. So partial fraction. A upon s plus 1 plus b upon s plus 3. So when we place s equal to minus 1, so it become minus 1 plus 5 upon minus 1 plus 3. So it will become 4 and it become 2. So 2 2s are 4. So 2 upon s plus 1. When we put s equal to minus 3, so it will become minus 3 plus 5 upon minus 3 plus 1. So it will become 2 and minus 2. So it will become minus 1. So here sign will be minus 1 upon s plus 3. So when we take the inverse, we will get 2 e to the power minus t minus e minus 3t. So answer will be first A. The question is given if the Laplace transform of the signal, then in the final value theorem. So to find the final value, we should remember that before finding final value theorem, we should remember the roots should lie at the left side only. But here what is happening? The roots are given s equal to 0 and 1. So when we plot, we will get s0. One pole will come over here and one pole will come over here. So roots are at the right side, so definitely the final value theorem will not exist. Why? The reason is because when we find the inverse of s minus 1, we will get e to the power t. So if e to the power t is there, then we plot it, it become exponentially increasing. So because exponential increasing function is there, so we can't find the final value. That's why it is unbounded function. Now next is a stable linear time invariant system has a transfer function this. To make the system causal, it needs to be cascaded with LTI system H1s. A correct choice for H1s will be. So they are asking the final resultant HS should be stable as well as it should be causal. So this will happen. HS is given as s square plus s minus 6. First of all, we will try to find the roots. We know the method. S square plus s minus 6 is there. So plus minus sign is there. So roots will be minus and plus. So 6, 2 3s are. So 3 and 2. So the roots will be 1 upon s plus 3 and s minus 2. These two roots will be there. So if we try to plot the j omega x's sigma, so minus 3 will come here and 2 will come here. So the condition is the system should be stable as well. Final system should be stable as well as causal. We should remember for stable system, the ROC should include j omega x's, and for causal it should be right sided sequence. So because here minus, if 2 we will consider, then what will happen? J omega x's will not come in the picture, so the stable system will not be there. So we need to multiply it by h1s. If we make it as, if we suppose that h1s is nothing but s minus 2. So s minus 2 will cancelled out. Now s plus 3 will come. So in that case, ROC will be this one only. So it is including j omega x's plus it is right sided sequence. So it will make it as stable as well as causal. So that's why h1s will be s minus 2. Now the response of the system GS is given. The unit step ut is yt, the value of dy by dt they are asking. We know that ys is equal to gs, that is s minus 2 upon s plus 1 into s plus 3, and it is given ut is given 1 by s. So first of all, by partial fraction we will try to find the roots, find the value of ABC. So when we put the value s equal to 0, we will get minus 2 and here 3. So minus 2 by 3 is s. When we put s equal to minus 1, in that case it will become minus 1 minus 2 and minus 1 plus 3 and minus 1. So it will become minus 3 and here it become 2. 2 multiplied by minus 1 is minus 2. So minus minus will cancel, minus. So it will become 3 by 2 s plus 1. And when we put s equal to minus 3, so it become minus 3 minus 2 upon minus 3 plus 1 and minus 3. So it become minus 5 and it become minus 2 multiplied by minus 3. So minus minus will become, it will become minus 5 by 6. So minus 5 by 6 upon s plus 3. So when we take the inverse, we will get minus 2 by 3 and it will become 3 by 2 e to the power minus t, and it will become 5 by 6 e to the power minus 3t. So now we have to differentiate it and putting t equal to 0. So when we differentiate it, we know that constant differentiation is 0, and here minus 3 by 2 it will become, I'm placing t equal to 0, so e minus t equal to 1, and again here it is minus 5 by 6 is there and minus 3 will get multiplied and it will become 1. So we will get minus 3 by 2 and minus minus plus, and 3 2s are 6, so 5 by 2. So it will become 2 by 2, that is 1. So answer will be 1. Now the Laplace transform of the function, we have to find the final value actually. So we know that when limit t tending to infinity is there, in s domain it become s tending to 0, s multiplied by 2 upon s into 1 plus s. S will be cancelled. When we put s equal to 0, we will get 2. So final answer will be 2. If you like my video, please subscribe my channel. Thank you.